Hello, everybody. This is Shaiful Hussein, and I have been a research assistant for Dr. Moss for the past several months, close to a year actually. Um, but today I will be making a quick tutorial on Clue.io and the connectivity map, which could be a great tool for us to use in the summer for our drug discovery project, in which we'll also have the ability to store our data so all of us can access it, and we will also have the ability to look at each other's data to make comparisons and whatnot. Even though we all have individual projects, Dr. Miles believes this will still be a useful tool in our arsenal. So yeah, we will soon, or actually, I believe Dr. Miles will um, make an account for all of us to use for our own project. Yeah, with that being said, to kind of start this process off, you want to find a gene set that is relevant to your own study. So for this test run, we're going to use this study right here, single cell transcriptomics of Parkinson's disease, human in vitro. You want to scroll down and essentially, so you could get this from a database or wherever you truly want to get it from, but for this test run, we're going to get it from the study. So yeah, I've already downloaded this, but essentially what this does is gives you the top X amount of upregulated or downregulated genes in the dopaminergic neurons of patients with Parkinson's disease. So yeah, I'm gonna just make sure this is sorted from Z to A. Great. So these are the most upregulated to the lowest. So I'm gonna take an arbitrary number of 150 because that's a max. Actually, yeah, I'll just take 150 because that's the max they allow. But you could take like any amount of genes that you would want to work with, and you could narrow your down based on your own study. So yeah, once you load up the website, this is not what you might see. So you essentially want to look at the top where it says tools, and you want to click on query, and then after that you could name it whatever. But I think it's best to include your name because I assume a lot of students are going to use it, so you don't want to get your data mixed up with someone else's. And then gene expression. And then everything else you can keep the same except the version. I find that 1.0 is actually the best version to use because that's the one that I didn't have any struggle with. So yeah, so you want to go ahead and paste your genes in the right slot. So over here in the upregulated gene slot, I'm just gonna paste all my genes. Um, it sometimes pastes weird in the format that they don't want it. So all you gotta do is just delete it and paste again. So yeah, it pastes on the right way this time. And one issue is you're gonna sometimes have genes that are invalid, um, or genes that are valid, like these, but are not recognized by the query. And in that case, you're going to have to just you could either delete it yourself, which I don't suggest because uh, the system automatically doesn't pick up on genes that it doesn't recognize, so it's not gonna mess up your data. So yeah, we're just gonna go on and go to the downregulated, do the same thing here, sort our data from A to Z. Perfect. Now I'm gonna take 150 again, just to keep it symmetrical. Nice. Same issue, paste it again. No problem. Okay, and then you're going to want to press submit. Now, this process might take up to an hour from what I have witnessed for myself, but typically within the 30-minute mark. But this really depends on your genes and the amount of genes you put, but I do not believe it takes more than an hour, so you should be good regardless. And then after after your data has been processed, you're gonna be listed in the side with the specific one and the name you gave it. So I've already done a couple of trials before, but we don't have to wait because I already submitted this, so we can just quickly take a look. So you're gonna want to press your new data that you have outputted. So you want to click on that, click on detailed list. You could use the heat map, but I prefer the detailed list because I think it gives you a more of a quantitative feel for the data. So once this loads up, you're going to be presented with a lot of information. 8,559 for this specific data set. But you kind of want to narrow that down to first look at the compounds. So click on the compounds, and then you see 2,429. Now, to kind of proceed with this, um, these are scored, but the only thing is these scores are not like probability statistical values, but rather a magnitude value. So you want to essentially find the ones that are the highest negative, or sorry, technically the smallest, but essentially you want to go as close as you can to negative 99. So that's what we're gonna do. Um, and we do have some data here. If I do not mistake, there's another one down that I can't access. Yeah, there you go. Yeah. So these are our top contenders for um, reversing the effects of the genes that we provided. Now we have some interesting things that are going on here. For instance, an acetylcholine receptor, which is very interesting because if you guys remember, our project did start off with us actually looking at Parkinson's disease, and acetylcholine has actually shown many relations to Parkinson's disease. Specifically, a study that I found where they look at acetylcholine receptor subtypes as potential drug targets for the treatments of schizophrenia, drug abuse, and Parkinson's disease. So we can already tell that we're on the right track just by this 10-minute worth of not maybe like 30 minutes worth of research that we've done so far. But yeah, so to kind of settle your data in and cross-check it is what I would go about doing next. So the way you go about doing that is you look at the specific compound that you're provided with, and then you look at the actually before you do that, you could look at the TAS value. So the TAS value is your transcriptional activity score, which indicates that a compound either has a strong and reproducible effect on gene expression through biological systems or it doesn't. So essentially, you want to see that it's not super low. Um, I think as high as you can get it to the maximum orange bar is probably the better, as far as I know. So yeah, that's one thing to be careful of. Yeah. So the next thing you want to do is look at the protein targets. This is actually how you cross-check it. So CHRM1 is a protein that this that this drug specifically targets. So what you could do is you could type the name in and then go up and then press on the gene knockdown list, and then you could look at the specific protein which is part of this gene family. And this protein has a score of negative 17.39. So there is a reversing correlation going on here, but not strong enough to the point where we can be like super convinced that this compound has a strong effect on our data. So you could go about this and check for all the all the data you're provided with. Just quickly gonna check that right here. So yeah, our data actually we're actually presented with a lot of cool things to explore here and research. For instance, clofibrate, which is actually part of my project and what I did in terms of PPR receptor agonists, which are shown to have strong effects in reversing Parkinson's disease. And so clofibrate is one that isn't heavily researched in the therapeutic field. So that could be a cool start of a hypothesis right there. And then ephrin inhibitor. So I've actually already searched this up, but there's actually studies going on um, looking at ephrin being a uh, especially useful for Parkinson's disease in therapeutics, especially looking at the specific dopaminergic neurogenesis, which makes sense because the data that we did start to provide is looking at the dopaminergic neurons and yeah, and looking at the stress of it or stress-related causes. So beyond that, once again, you could look at the protein that it targets and narrow it down on that. Another one like over here is like a MTOR inhibitor. So this one obviously targets MTOR as it says on the CMAP class. So you'd go about it the same way. You just search up MTOR, and you would go up, you would press on the gene knockdown menu, and then you would be provided with the gene knockdowns. And then looking at MTOR, you could see that although it has a strong TAS value, it doesn't quite have the score we're looking for. In fact, it has a 0.00 score, which kind of tells us that there's not much connection going on or connectivity going on with our data here, which is not what we're looking for. So this process could take a long time as you need to constantly double check and cross link these um, certain compounds and the protein it targets with the knockdown knocking down that protein, see how the data is affected. But once again, these compounds do decent bit more than just affecting like set proteins. So just because like some things might not be as strongly correlated does not mean that this compound itself is completely useless. So I would also be careful about that. But yeah, essentially this is a great tool that I think would be very useful in our upcoming summer project. Anyways, thank you for listening, and I hope everyone great success for the upcoming summer projects. Goodbye.